In this video, we're going to investigate how to find the point of intersection between two lines. So this is taken from page 562 in your books. This example is worked out on that page also. So we have the line M and we have the line N. So the first method of finding the point of intersection of two lines is to graph both lines, and we've seen in another video how you graph a line at the x-axis. Y equals 0, so at the x-axis y equals 0, so substitute in 0 for y and work it out. So two zeros are 0, take the minus 4 across, turns into plus 4. So the coordinates of the x-intercept where it crosses the x-axis is 4, 0. Then we do the same for the y-axis. At the y-axis the value of x is 0. So we substitute in 0 for x into our equation. So 0 plus 2y minus 4 equals 0. So 2y equals 4. Two somethings are 4, y is 2. So that's the y-intercept, 0, 2. And we do the same for this line at the x-axis. The value of y is 0, so substitute 0 in for that. So x minus 0 minus 1 equals 0, so you're taking 1 across, so it turns into plus 1. So the coordinates of that intercept are 1, 0. Likewise, at the y-axis, x equals 0. So substitute 0 in for x, so 0 minus y minus 1 equals 0. So minus y equals plus 1. So multiply everything by minus 1. Because it's y you're looking for, not minus y. So the coordinates of that intercept are 0, minus 1. So graph the two lines now. Just a little sketch is fine. It doesn't have to be perfect. It's just a sketch. So 1, 2, 3, 4, and 1, 2, 3, and we'll go down to minus 1. I only need to go up or down as far as these points here. So this first point, 4, 0 and 0, 2. So that's the line M. The line N crosses at 1, 0 and 0 minus 1. So that line looks like that. So there's the point of intersection of the two lines, which I can read as 2, 1. Now that's the first method of doing it. There is another method of doing it, again, that you would have studied in Junior Cert. You can find the point of intersection by solving the simultaneous equations. So we have the first equation, x plus 2y equals 4, and the second equation, x minus y equals 1. So that's just these two equations at the top that I was given. Okay, and I've just brought the minus 4 across, and I brought the minus 1 across. So down here I have this equals 4 and equals 1. Now in a simultaneous equation you're trying to get rid of the x's or the y's. So I'm going to multiply the bottom equation by 2. That will get rid of the y's. And remember, you're multiplying the entire equation by 2, not just the y term. The top equation remains unchanged because I don't need to multiply it by anything. Now if you look at the y's, 2y minus 2y, the x's add up to 3. So 3x equals 6. 3 somethings are 6, x is 2. So now that I know x is 2, I take x and I substitute it back in here into my first equation. So replace x with 2, plus 2y equals 4. 2y equals 4, the opposite of adding 2 is subtracting 2. 2y equals 2, two somethings are 2, y is 1. So bring these 2 points together. I have the point 2, 1, which is the same as the graphical method. If you're asked which one is better, solving it using a simultaneous equation is more accurate, because the graph only gives you an estimate.